welcome everyone. No. Some reason I did.
He does have like a half-hour commute for the day.
It just projected to the desktop over here. It was oh, it's here right now. But if I play it,
It popped up for a second and then
okay.
that's what you say you use the insurance stats teacher.
Okay.
Really good.
Everyone, welcome to this class. Especially for the new ones. I haven't had you in my class since you came here many years ago. Probably wondering, Dr. Lee never teach at all. So this is a really exciting topic, embedded devices. You may have heard about embedded devices for a long time, but what are they in general? What does embedded mean? You put it into something, right? If you think about for example, the printer over there, it does have a little PCB board in there with a CPU and memory chips. So you put that PCB board with peripherals, for example, communication ports, memory chips, and CPUs onto the board, and you plug into that printer, then that PCB board is an embedded device. It's being embedded into something else as an independent device to run some algorithms or software on it. Okay. So I want to let you take a look at the IPG, one of the embedded devices we're going to use for this semester. Okay. So this is called a FPGA board. FPGA stands for Field Programmable Gate Array. If you take a closer look at it, it does have it's called system on chip. It has a CPU, or if you don't program a CPU on it, it's going to be just a logic gates. You have learned logic gates in computer logic in that class 241. So logic gates are just transistors. You have simulated some of the logic gates in LTSpice. Okay, so you can program all these combinational or sequential logic onto this FPGA chip. But it's different from the Arduino chips, like the microcontrollers you have used in MNI or some other courses. Because when you are programming this chip, you're not writing in C language. It's not storing any software in it. So when you program in Arduino, you program in C, and then it's being compiled into assembly and then machine code or 1 and zeros, right? And they are being stored in the program memory, and the CPU is taking out every single line each time to execute the code in the CPU. But this will be different. If you're not programming any software into it, not using this guy as a system on chip or microcontroller or CPU, you can just purely program hardware on it. It's very similar to the procedure when you wire up all the circuits in LTSpice or any other simulation tools. You build a circuit, right, and then you wire them up using the GUI. But actually, when you are programming or wiring up circuits in this chip, you imagine that there are some gates or transistors already available in the chip, but you use a program called Verilog or hardware description language to make the connections instead of using your hand and mouse to wire them up. It's the same procedure. So when you program a hardware like that, don't think that you are programming in the software. It's not a software programming, it's a hardware programming. It sounds interesting and weird to you guys probably if you haven't done that in the past. So you're programming a hardware instead of a software. Okay. So when you write up the language in the GUI or in the IDE, it could be there's still a variable. For example, we call it y as output. Okay, and we just directly write up A and B. So that's the AND logic. It's the operator. So the signal A and signal B there are physical wires and physical signals on the chip. Okay, so these two signal lines are being ANDed, and then the result will be assigned to Y. So if you write this in the programming environment of this tool, which is called Vivado IDE, you program in there, and this piece of code will be synthesized. All right, and then it will make certain connections into the chip and build a little AND gate in there. So that's the difference between the hardware programming. It's called hardware description or HDL. So there are two main HDLs. One is called VHDL. Another one is called Verilog. So VHDL is very popular in a minority of companies in the US, but this is more popular in the US. But in Europe and India, I think VHDL is more popular. But in China and the US, Verilog is more popular. But they are very similar, but with very tiny grammar or syntax differences. So in this class, we are going to learn Verilog. And in the future, in the company, you do need to learn VHDL. It's going to be a very simple transition. Just learn the basics in that language. Very similar concepts behind them. So let's come back to this port, okay? That's a VGA port used for display, and we're going to learn the back end of the VGA towards the end of the semester. So we are going to design a digital controller to control VGA from scratch. So you will learn the basics of every single piece of VGA communication, including USB as well. There will be an intermediate chip it's a microcontroller chip over here. We'll do some translation in between your USB of the laptop and the FPGA board. But eventually we are going to use the keyboard and with a USB plug to communicate with the IPGA, design a little USB controller using this chip. And this is just a display module. So we're going to program something to display a clock or a timer, something similar to that, into or calculator using this business board, right? And there are some peripherals as well, ports. So these are connected to the pins of this FPGA chip. You cannot see the pins over here, which means you cannot really solder them, use your iron. So it has to be heated up by a hot plate because all the pins are underneath it. These are switches. We'll play with the switches a lot this semester, push buttons. So that's a port that you use to program this chip. It's a micro USB. I'm going to give you a cable and a board to each of you. And this is the switch, the power supply. That's everything about it. Pretty simple board. It's a very basic model of the Xilinx IPGA. And there's an advanced version of it. So in the future, it could be a senior seminar project or something else. If you really want to learn more about FPGAs, you are more than welcome to do that. That board from the same company, it just has more peripherals. It has a HDMI, Ethernet port, a little OLED. So that's the chip, that's the CPU. It's probably running way faster than the previous one here. So it's generating a lot of heat. That's why you need a heat sink on the top. Audio ports and VGA as well. And I think these ones are for debugging. That's SD card adapter. So you can store data to the SD card. Right. So FPGA is one of the most critical technology existing on the market, I think. You can say like FPGA or embedded devices equals to jobs. There's just so many job opportunities require IPGA skills. We have a lot of alumni. You can see on the posters there. Most of them have a position. The name of the position is called embedded software or embedded devices companies or positions in the industry. And so if you learn IPGA technologies, you can check a few more boxes on your resume. For example, IPGAs, Verilog, embedded devices, etc. And it's really good skill to have. So IPGA is just one of the ways to prototype integrated circuits. If you think of, I'm just talking about too much here. I think it's, for some of you guys haven't taken my digital electronics courses or other microcontroller courses, it could be a little bit overwhelming. But we'll get into it very soon. Now I'm just giving you a quick overview about the industry and the market. Okay. So when people prototype or design a CPU, it could be for a smartphone, for desktop or laptop. So all these CPUs or memory chips or any other communication digital chips, when they are trying to design it, so they have to verify the logic with IPGA first. Whenever you run it's called tape out, which is the fabrication of the integrated circuits, especially for the very small technologies, for now like 5 nanometers, sometimes 20 nanometers. So whenever you want to tape out or fabricate a design to verify it from the company in the industry, it can cost you like $1 million to just to get one prototype or one testing chip. So if you make some mistakes in the chip, usually it happens a lot because they'll have like billions of transistors in each chip. If there's some errors in the chip, they have to do it again. It's another $1 million. And a lot of times, it probably takes like 100 times to eventually, or even more, to eventually get a functioning chip. So it's definitely not affordable and not the right way to do it. So that's why IPGA is the best option or the only option on the market that people can verify their chip design using the hardware discrete language. That's how they design their chips, and synthesize it and download it to IPGA and test it on the hardware to verify the logic of the CPUs and the memories and the communication chips before they send it to the foundries for fabrication. Okay. The cost is almost zero every time you run a new design, a synthesis on the IPGA. If the first time you buy a board like this, it's like $1,000. But every time you run, it can run probably for like over 1,000 times on the board. The cost is really low. Until you are confident about the logic, the sequence, the timing of your circuits, then you send it to the foundry for fabrication. Even that, it probably will still fail for like 5 times until you get a functioning chip. So that's how that works. So you can see there will be more. It's just a team in companies like Qualcomm, Samsung, or ADC, or some other companies existing in the country. They're probably paying a starting job, for example, $150,000. That's pretty much the average salary when people working in the industry, working on either IPGAs or any other step in the workflow. So the verification positions, the verification team, and the digital design team is probably the first team to start up the project. So whenever the verification, the design and verification are done with IPGAs, they send it to the cadence team, which like people will start doing the layout, transfer the circuit, the hardware description language into a physical circuit on the chip. And then there will be another team to work with the foundry for the fabrication of the chip. Okay, so they are paying probably the same, but it doesn't matter like which one you really want to work with, which team you want to work with in the future. But I think for this class, you're going to learn the front-end design of the whole workflow of the chip industry, which is converting the hardware discrete language, which is the chip design, into a programmable synthesized file on IPGA, and they'll verify the logic on IPGA using the peripherals. It could be switches or display modules or a monitor. Okay, it could be a bit overwhelming for now, but you'll get into that very soon. Okay, so only thing you need to know now, I think, is this is a fascinating field, and you'll learn the skills from here, and directly you can apply it to find a job. When So during the interview, you can tell them you have used the Basis 3 FPGA board. It's really legit. Don't be shy to talk about that. It's okay. It's basic. It's a fundamental or for beginners FPGA board, but it's still very okay. You just tell them you have used the FPGA board to do like USBs, VGAs, and displays, and eventually towards the end of the semester, you use the soft core, which is CPU. You embedded the CPU into the FPGA to run the little microcontroller on it. So it's all these experiences are pretty amazing. I think if you tell the employer you have done these projects, I think they'll like that a lot. So for most of the time, when I was in college, teachers usually teach the basics and the programming and run some simulation in the class. I spend most of the time in the class to tell you how to program, okay? Which doesn't work really well. So sometimes you have to write the code on the paper. Sometimes you run the simulations, but rarely you demonstrate it on IPGA. But I don't like that since I found that that's not really helpful. Could be really boring. Converting a really exciting course and technology into a super boring class, which is, sort of stupid, my point of view. So my preference is to have weekly projects. So if you follow just a super tedious programming and simulation towards the end of the semester when you are trying to add something to the resume, you couldn't really, talk too much about it. What are the project experience you have? Not too much. But if you follow all these weekly schedules, the schedule, and finish every single project each week, this is just for the course. Okay? If you look at the lab, so you are going to practice the similar technology or skill set in a slightly different way. So eventually, you are having probably, if you have 14 weeks, it's probably 12 projects for the lecture and 8 projects for the lab. So you're getting like 20 small projects, small or medium scale projects for the whole semester, and you can add a lot of things on a resume. Talk about that during the interview. So there are some applications for embedded devices. The first one, which is one of the ongoing effort we have in the department. So the goal is to design interface circuits for quantum computers. The quantum computers right now, we don't have a room temperature quantum computer now, so they have to be cooled down to very close to absolute 0 degrees. So that's why you can see the CPU and the GPU and the quantum computing, the core is being kept in the tank, which has a probably liquid helium in there to keep it cool. But that's not the only thing we need for the entire computing process. The CPU is running all the computation, but we do still need interface circuits. Okay? So in the future, you are not imagining a quantum computer in your pocket, but you can definitely have a quantum computer being stored in somewhere, for example, in the headquarters of Google in Silicon Valley, in a huge building. It doesn't matter. It doesn't have to be small. We just need the quantum computer to run something really fast, right? Like ChatGPT, you send some commands or questions to ChatGPT, but it's being executed in somewhere else. So if we can do that, okay, then we still need interfaces or ASICs. It's called application-specific ICs or CPUs to communicate with the quantum computer at the end for the end users, like the terminals. Could be smartphones, laptops, or something else, right? Then we can still achieve a way faster computation by doing that. So that could be a huge market in the future. So you can see, even though there's a revolution in quantum computing and AI, but we still need engineers to program, FPGAs and also prototyping ASICs or chips. So silicon will still hang around for another, 50 to 100 years. I don't think anything can replace silicon. So these are all based on silicon. Right? So still silicon. And you can see there will be a huge market and demand on the market for digital design engineers in the future. So definitely pursue this career is a market option. It will pay you a pretty decent salary at the very beginning, but in the future, you still have a lot of room to improve as well. Oh, I haven't talked about that. So this one is a $75 million grant that Fortis College is a part of the team working with Sandia Lab, trying to get the grant. So we probably are eventually receiving $500,000 to support students' activities on FPGA development for interfacing circuits with quantum computers. And we're competing with a team in the Chicago area, so you can consider this about 50% chance we can get the grant. And hopefully we can, if we win it, we'll be able to receive the money starting in this fall, this year. We can start having students on board to get trained. Another project was just funded to North Dakota State University. So Fortis College is a sub-awardee of that grant from the Department of Transportation. And it's a $3 million grant for the whole team. You can see Fortis College is just one of them. And what we are going to do for this project is to monitor the scour of bridges. You can see the fast flow of water can cause a scour of the bridge, which is a hole at the bottom. So it's losing the gravels and sediment of the pier, and eventually will be one of the main reasons or causes of the bridge failure. So one of the teams at Fortis College 2 years ago, the senior SAM team, designed a mounted monitor. You can see over here. So it's mounting a distance sonar sensor to monitor the distance of the riverbed to the sensor, to probably plotting a profile of the riverbed, showing the colors and depth of the riverbed in order to monitor the scour of the bridge of the pier over time. So it's being powered up by a solar panel. They don't want too many people to go there. It's increasing the cost of labor, and the maintenance cost as well will go up crazy. So that's why they are trying to find a different way to monitor scour. You mount one solar powered scour monitoring system, which is about $3,000, to one pier is fine, right? So what if you have a bridge look like this? A single bridge has probably over like 20 piers, and in that case, you cannot really mount like 20 of them to each pier. The cost will be high. So that's why we are trying to use an unmanned boat or underwater autonomous boat to go around that pier, each pier, and to map the riverbed and send a signal out to a computing center or something, and then to send the data to the Department of Transportation that way. So it's going to be a robot project, pretty much. And there will be two students be supported for 1 year. And it's a 5 or 6 year project, so it's a long time, and eventually we'll build something, right? And which is able to map the riverbed. I'll probably start, hiring students for this summer. If some of you are interested in this project, definitely reach out to me. Another one is from EPA, is starting this January. A few students have been working on this for a long time, but so this time we have a different goal here. A few students in the past already built this PCR system, which is a thermal cycling system, to heat up the DNAs in order to detect bacteria from the environmental water samples. It does have an embedded device, which is a very simple microcontroller in it, okay, to control the temperature. And this was functioning, okay. It has a Raspberry Pi display, it's a touchpad, has a GUI in it. So students use C++ to write a GUI, and so people can modify the temperature cycles in it. So I think everything has been published to GitHub. If any of the students in the department can really take over this project, we are trying to make this one open source. So the main role here will be maybe validating the functionality of this PCR system and redesign it, make it smaller, and looks more like a product, so we can probably sell it and have an open source PCR system online, which will be the first ever PCR open source PCR low cost PCR system available for all the customers. And we're also going to integrate some of the droplet digital PCR, which has been developed by Ian Mason. Hopefully, if it's functioning, we can integrate that module into the system as well. So you can tell that the machine is being used for a specific application, and they do have embedded system in there to reach the goals. It could be a thermal temperature control, could be a communication with the touchpad, could be a lot of things. So after you have learned embedded systems, whenever you see or find different devices in your car, in your house, you can understand a lot of things running behind the scene. You understand why it's working like that, in that way. And there's another one we are competing with other teams in the country, and probably will start recruiting students next year. It's an ionizer project. We're trying to use ionizers to clean up the air in the for indoor environment. You can see it's just a very simple voltage generator, okay? But we want to control it. For example, I want to turn on the ionizer for a certain period of time and turn it off. And also I want to sense the temperature and the particle data, the number of particles in the chamber. You have to use a certain type of sensors and communicate with the microcontroller, which becomes another embedded system in the whole design. So you always need a CPU, which is a smart hub in the system to work with all the sensors and emitters and everything at the same time to collect the data, as a control hub in the entire device. So this is another embedded device or example of the embedded system in our research projects. For the weekly plan for this term, so this week we have today and Thursday, and you have another 3-hour lab on Thursday, so it's pretty intense. Eventually, we will be able to have all the tools, including the Vivado, the programming environment, the FPGA board, and the Vim. You'll need to program in Vim. I'm going to show you later because it's a very critical skill to have. Have you done that? Did we know a little bit? So whenever you have to, it's just a very simple editor, but has a lot of commands in there. If you work with a company, a lot of times all the software are not being run on a individual laptop. It's not run on PCs. They're super expensive. They are all hosted by a powerful server, and everybody will log into the server using Linux commands. And if you want to write a script in Linux, usually it's Vim, it's the VI commands. That's probably the only way you can do in that kind of massive projects. So always log into Linux and using VI to program. So definitely need to know how to write code, the scripts in VI or Vim. So here's the right time to practice that. Okay. So you're checking another box on the resume as well. So first week, get a programming environment set up on your computer and program the first ever FPGA or Verilog code on in Vivado using VI or Vim, and learn how to upload your lab reports to my website if you haven't done so. For example, Sarah, Joe, and Lucy, probably you haven't done that yet. I already sent you an account to your email this morning or last night. Try to log into the server and write a report and upload to the server. Okay, so there's a tutorial on the website I'm going to show you in a bit. And following that first week, we're going to learn more details about the Verilog, how to program an IPGA board using Verilog, including dealing with all different data types, the racks, the wires, and everything in Verilog, and design computational logic blocks. You have learned logic in 241. So here will be a very different way to design a digital circuit. Since we are talking about computational logic, I want to let you guys think about it instead of I'm always talking. So you have built digital circuits in LT-SPICE, right? So including a little transistor and putting the transistor together to make a gate. And then you build a adder or something using the gate or different gates. So in a physical world, if you want to build a physical digital circuit, you have to grab a breadboard, right? Grab a breadboard, and you can take some of the logic gates from the drawer. They can be little IC chips. So the chips has 1 or 2 AND gates or OR gates in there. You plug in that chip onto a breadboard and you wire them up. They can build a little adder on it, right? It's going to take you probably how long? You have done some Circuit One labs, right? You put the parts, the chips onto the breadboard and wire them up, make the connections, and inject signal into it and test it using oscilloscope. You can see the waves or the digital circuits, the digital squares, the waves, pulses. For most of the time, it's going to take you probably a day or half day or 3 hours at least to build a very simple digital circuit or to verify something. However, if you are using FPGAs, if you want to design some digital circuits, can be something, it's just a one line of code, like A plus B and assign it to C. All right, and then synthesize it and upload the code to this FPGA. It's going to make up a adder into the chip. It's a physical adder. It's not something in LT-SPICE. In LT-SPICE, you are simulating the whole thing on the CPU of the Intel CPU in the laptop. But here's different. Okay, you write an adder in Verilog in the hardware description language, and you synthesize it. Probably take you like 2 minutes. Okay, and you upload to this FPGA board. It's going to make a physical and the physical adder into the chip. You couldn't see it because they are just in the silicon, probably nanometer level with the CMOS circuits. Instead of you put everything on the breadboard and verify the digital circuit, which is probably 80-year-old technology.
How does it make the connection?
Physical part of it, right? I couldn't tell the details. I was looking at the diagrams. It could be some lookup tables. I don't know. I don't know how they burn it and reconnect it in the physical level. We don't really care about that for here, but we can definitely do a look into that later.
I was just curious.
Yeah, yeah. So it's going to be a physical circuit on the FPGA instead of a software or anything else being simulated in the Intel. All right. We have 2 exams. One is a midterm exam, one is a final. Yeah, I don't like too many exams. It's taking the time away from learning new things. But definitely just one final exam will be not that good, right? Keep you on your toes. So one midterm in week 7. UART, if you have used Arduinos to look at the data from the serial monitor, have you done that in the past? So connect Arduino through the USB, then you open up the serial monitor. You can see data being reported through that serial. So that's a UART communication protocol. That's a UART port, universal asynchronous. I forgot the full name of it, but that's also called serial. Then we have a Spring Break, but after that will be a soft core, will be a CPU being programmed and implemented into the chip. Then followed by two more projects. We'll have a final exam. Okay. So there will be a course project as well, which is making a game on IPGA. Use a joystick. Okay, disconnect on the internet. I was asking Max to finish that tutorial on the Yoshi's Nightmare tutorial. So it's going to be a joystick being connected to Arduino. Because the joystick is outputting voltages, analog voltages, so I have to digitize it. So I don't know if this one has an ADC on it, analog to digital converter. So it's probably just a pure digital device. I only understand 1 zeros. However, Arduino has a 10-bit ADC. So joystick outputs continuous voltages. So that voltage has to be digitized and then being sent to this IPGA board using digital signals. And he posted all the scripts to GitHub, apparently. Okay, hopefully we can make that happen. It's gonna be a really interesting game that you are going to connect the VGA port to the board, and there's a joystick connect to the Arduino and then Arduino to here, okay? And use the joystick to control it, send a signal to the IPGA. The IPGA will relay it to the VGA. Okay, so the VGA is directly connected to the monitor. So you disconnect the monitor VGA from the tower, from the desktop. So you're just using a monitor. Okay, so this one will directly communicate with the monitor and display a game interface in there, and you can use your joystick to play it. Okay. That's a course project and grading policy. 10% midterm. That's an exam. For each of the exam is 10%. Homework and quizzes. So homework assignments are the reports that you post to the website. It's 35%. I'm gonna give you an example over here. From one of the past students. So I want you guys to organize your website like that. So you are going to take probably multiple courses from me in the future. So if I click your name on the website, it's going to open up a pretty clean web page, shows different courses. Okay. So for example, I click the embedded devices course. It doesn't have to be a table, but it definitely should list all the homework reports and lab reports very clearly on the website. So for example, if I open up one of them, you can see the explanations. I think he drew this probably on the iPad and then make a snapshot as a figure and insert the figure into the HTML web page. Okay. Yeah, I think these are pictures, not, okay, so this is a picture. The simulation snapshots from the software, from the simulation environment, the code, and results, and a little bit description of each task, and a discussion of the whole homework assignment. You can talk about what you did and the issues you had and how did you solve the problem, just briefly. You don't have to write a long paragraph over here. So if you just plug in figures without any description or explanation, I'm going to take some points off from that. It cannot, so it's not a lab report, right? Just plugging figures into it and didn't see anything about it. The lab reports are very similar. Plugging videos into it. So he removed the videos from the YouTube account, but let's take a look at some other examples. Yeah, this is what it is. So create a YouTube account, and when you upload your demonstration video to YouTube, you don't have to list it. It could be an unlisted video, so other people cannot see it, right? And then plug in that embedded HTML code from YouTube. It's very easy to do. You click there's the embedded. So I think it's one of the sharing options. You click it, it's going to show you an embedded HTML code. You copy and paste that one into your HTML web page, and it's going to display a embedded video window in there. So do not just copy and paste a link to the YouTube video here. Please have a window like this. Okay, I can directly click and play. Okay, so it's not directing me to another website. Right. So what it did here. This is one of the demonstrations we had. So you probably already know that YouTube has shorts. Whenever you submit a video less than 1 minute, probably they will, by default, they will convert into a short instead of a video. So the short is really annoying from my point of view. Is a lot of times I cannot change the volume of the song and something else. It's just not really convenient. So there's a way to change it to, yeah. You can change it, right? So remove, so on the link, the URL, you can remove the short and change it to watch blah 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 something. So you can Google it really easily. I think I did it in one of the tutorials, but I couldn't find it. But whenever I find it, I can send it to you. But also I Googled it. I find out that solution. So please definitely make that modification to your video. Don't, if you can, don't do a short. It's pretty annoying.
To embed, and so I couldn't switch it from shorts to the watch while also embedding it.
That's what I'm pretty sure there's a solution to it. That's what I did, but I forgot to put it into the front page. I think it's in one of the lab tutorials where I did it. Hold on, I can find it somewhere. Yeah. That's right. Yeah. So you go to the watch, the link with the watch on it first. Then you find out the embedded code from there, right? Instead of using the shorts. This is the main page of the website. If you haven't been in my class, you want to know that. It's electronics.com. You can find a lot of information from that website. I rarely use Canvas. I posted the syllabus over there as required by the college. I can manage 2 sites at the same time, but I found that it's really not necessary. But I also realize that most of you guys are really relying on the timeline on Canvas to really use it, looking at the deadlines and using the, like these days, the to-do things on it. So that's, yeah, I know. So I can do that, but it's gonna take me a lot of time to manage 2 sites at the same time. Let me see if I can do it. But if I, just in case I find out it's just too much for me, I have to do all the ground writings and everything else, then please, I'll let you guys know there's something like due at a certain time point. But most of the deadlines and the tasks will be posted to the website. And because you guys are going to open up this website and follow the tutorials anyway, so I'm pretty sure you probably will open up this page multiple times a week. So definitely see these dates over here, the deadlines and everything. Pay attention to the dates. And if I update the dates over here, I'm going to send you an email and tell you they're updated and when they're due. Okay. So writing and formatting of the reports will take 20% of the whole grade, and technical demonstrations will be 80%. Because I didn't have these detailed rubric last time, so I saw a lot of different types of labs, and which looks ugly, and I hate it. So whenever I see a very good formatted report, and then the next time I click and see a super ugly report, I feel bad for the whole day. So I want to have and also I feel on fire, for giving totally different types of reports a same grade, the 100 here, 100 here as well. I hope everyone can keep a very clean and formatted report. It doesn't have to be exactly following the format. You don't have to write a lot of contents in the paragraph, but you just have to, explain and describe what you have done a little bit in there. And it must be a YouTube video instead of a link, just a link on the website. All right, any questions by far? Are the reports in the video? What did you mean? No, the reports. Oh, individual. Yes, not a teamwork. So probably in the end, the project will be a teamwork. But I have to consider that. I have to think about it. How can we split the tasks? But sometimes I feel it's more beneficial for you guys if you do an individual project. Sometimes it could be a collaborative project as well. Or they'll have pros and cons. I have to consider that. Okay, but for all these labs and tutorials, they are individual work, not a teamwork. That's a good question, actually. Because most of the labs you have done in the Circuit One lab or other labs, you have a bench, you have 2 or 3 people work on the bench at the same time. Now you have to do it independently. But you do have somewhere to get help. Okay, so if you look at the other people's reports, okay, here, I'm not afraid of let you guys know that because it's not as simply just a copy and paste. It involves a lot of other things. For example, make the connections, and it's just a lot of other things. So, but sometimes you want to refer to other people's code, but definitely not directly just copy and paste. If some plagiarism is detected, I'm gonna send an email to you guys and let you guys know. If that happens twice, probably you'll fail this class automatically. So you can definitely refer to other people's report. I ask them to not posting the entire code to their website. So I think most of them did that. But definitely the code is not just the only thing you can get through the project. There's just so many other things involved. The wiring and other things, debugging. Okay. So you will get help from other people's report definitely. And so here's where you find out how to edit your web page. So first step, go to my homepage, electronics.com, and click the labs link. So you can find there's a tutorial on how to edit your web page.
As I'm in the midst of applying for residency right now.
To a YouTube video tutorial. And you can download that's a FTP tool that I can upload your web page and your reports to the website. And there are 2 templates you can use. You can also create your own HTML pages. I showed you how to do that very easily in this video. You can directly just create a new text editor, text file, and start writing up the code, the HTML code in there, and convert into a HTML format. So all the links are already created on this web page. So you click the lectures web page and the students reports. You can see everyone has a link over here. So the ones already took my class, you know how to do it. But now, let me just, for example, click Jules. Okay, I copied and pasted a course template into a working space on the server for your account, and so you should change the title and change everything over here, and have one link. It's CE433 embedded devices in there, and then if you click that link, it's going to direct you to another web page, shows all the like homework 1, live 1, all those kind of things in there. Okay, so you can create links in your HTML web page. Same to Sarah's and Lucy's, Taylor's as well. She's not here today. Okay. Any questions by far for the general stuff of the class? We're gonna have a 5-minute break, and then we'll cover some basics of the tasks for this week. Any questions by far? Okay. Okay.
When's our first assignment?
Usually next Tuesday at the beginning of the class. All right, it's a long lecture, so it's 1 hour, 1.5 hours. So let's take a 5-minute break in between.
So we have a for this week.
Yeah, so it's just a due date. It's gonna be next Tuesday. Yeah, the homework is already in here. I have questions at the end of the tutorial. Specific tasks.
Oh, okay. I see. So these are like the tasks.
Yeah.
So this is what we need to do. This is like.
Yeah. So there's the tasks. See, 5 tasks.
I see.
So you go through the tutorial, right, and then finish the tasks. That's how I teach anything involved in programming. I've taught 104 at the very beginning of my teaching career at Phillips College. It was like, everyone please turn on MATLAB. Then only half of them were able to turn it on. Then I start helping each other. All the other people are waiting.
Yeah, when I remember this programming classes, I remember just like 90% of the class was sitting there doing something else, just simply because I could type faster than everybody else. Like it wasn't like a skill thing, you know?
Yeah.
Which computer did you select? And does it happen? Yeah, right. Did IT actually install what you asked? No, almost certainly not.
The first couple of years, they did because I forgot that person who left. Just looking at your eye, he was a really good IT guy. Will make sure everything works.
Get him. I just said you must have plastic lung. He was actually too good for his job. He had to fit him.
He's found the good voter. It's like.
Got a long enough password there?
Yep.
We have a new static graph. Oh, really?
Yeah.
I think I'm gonna have to get a membership for this semester.
Yeah.
I have too much, like, I don't have an off day where I can go find really.
Yeah. So you are getting a membership?
Yeah, probably.
Yeah.
I think it would go crazy if I can't do anything but homework all day, every day.
Yeah. It was pretty good. It wasn't, definitely wasn't like the best set.
I feel it, like a lot of their sets I feel like are hit or miss. Like sometimes you get one or two like cool climbs, and then other times it's just like, okay, this is just drag. Wow.
It's honestly a lot of it's just the dang walls that they have.
Yeah.
Can I just get rid of this?
I don't know, because you tell it to switch when I'm not using Teams, and then like 10 minutes later it'll pop back up and be like, you're not using me, do you want to switch?
Yeah.
And it's like, I'm not using you because I don't want you open.
Yeah. Yeah, they just messed up when they built that shit. I don't know what.
I think it's just because if they did everything overhang, then what are the players gonna play? Like I feel like most
Like
of
they
their
could have done
notes-
half of the gym at least slightly overhung
Yeah.
instead of like 1/5 of it.
I wish they had some gradient to the overhang. 'Cause there's that one really steep overhang and then slab.
Yeah.
And it's like, okay.
It would be nice if they had like a steeper one and then that one in the middle.
Or if they just ripped out all the top roping crap, because who the hell top ropes there?
Yeah.
And put in some
The wall
decent
that's
overhang.
5 foot
I
high.
don't think I've ever seen someone.
I've seen a bunch of people and I'm like, what are you doing?
Like why?
It takes you 20 minutes to tie in and stuff, and then you climb 3 moves higher than you were going to.
That's just,
And the rope sets don't seem particularly good either.
no, because
Some of them are all right.
if I was setting ropes, I would just be like, this is bullshit. Like,
Yeah,
this is so
setting
silly.
ropes
I really enjoyed setting.
It's just such a big gym. They don't have.
There's
to,
no competition.
They don't have to do much.
Yeah.
The customer base is going to be there.
I'm just happy they have a Kelter board. That's the main reason I want to get a membership, is just so I can get a Kelter board.
It's a bummer too, because the only like good, like professional setter they have is Charlie.
Yeah.
And he can't reset the whole gym every time. Yeah.
But they have to pay him a little
Yeah.
more probably. That guy probably makes minimum wage.
Yeah.
I had how many students by far from the C department? Maybe 20, just 30-ish. Yeah, it's not a big department. 15 graduated by far, and you can tell most of the graduated students are pretty good. So the ones couldn't do computer engineering dropped out at a very early time. So the graduated ones are pretty good, and everyone who loved software engineering at the very beginning eventually switched to kind of hardware, but you are the most stubborn person I have ever seen. The reason, I think there are many reasons for that. First, we didn't have a lot of software engineering projects towards the end of the college, the third and fourth year. So I was pretty much the only person teaching all these 300 and 400 level courses, and most of them are computer engineering courses, not computer science courses. So including IPGAs and microcontrollers and a lot of PCB design projects. So people who were doing a lot of internships during their 4 year in the college here, they took their summer with some of the software companies that are getting really good pay. For example, Taylor Nakai, right? He was one of the person considered himself as a coding person for a long time. Until the 3rd year, he started taking my classes. He started being obsessed with all the computer engineering stuff like IPGA and microcontrollers, and eventually found an IPGA job in Sandia. In Sandia. So this has been happening for a long time. I hope you guys will enjoy this. So all the set of courses, starting with microcontrollers to IPGAs to digital circuit design, will train you on pretty much every single layer of the computer engineering industry, from the very bottom IC design to IPGA prototyping to the higher level microcontrollers. It's a very complete set of skill to be ready for the interview for the industry, I think. So it's a really good skill to have. So first of all, I think we should start, let's look at the tutorial here. It's gonna be Vim, right? Do you have Vim on your computer? So if you type start and type gvim, probably. Do you have that little app?
Yeah.
Cool. Could you open that up? So it's gonna be something like that, right? Could you? Yeah, I don't know if we need to get rid of that. So if you want to start typing in there, have to type I first, which is the insert, right? So you can insert things over there. Okay, type whatever you want, but you have to type I first. So I stands for insert, right? If you want to quit that inserting mode, you have to press escape on the keyboard, right? So insert something, right? For example, print, it's a Python code, print hello world. I know we are not programming Python, but just example, print hello world, right? And then escape, okay? And shift colon will get you into this mode. If you type W, which is write, so it's going to write that one into this editor, so which means it's going to save it. If you type a Q, W and a Q in there, it's going to save and quit. So I don't know if I save and quit, where it's going to save it. Okay, so it's not doing anything. So let's save it as, click File, and Save As. I just put on the desktop. Just call it test.v. So the Verilog file is going to be, so I click the File and Save As. Okay, click File and Save As. I put it on the desktop as a test.v file. So .v file is a Verilog file, can be loaded into the programming tools for IPGA, and I save it. So I believe it's saved on the desktop over here, this one. And usually they will create I think this is a backup file or something. I'm sorry, it's too small. But there's a way to change the GUI font.
One minute in the code. It went exactly how he said it would. What am I doing? I can't get out of it. What if you do the file save as?
If mine clicked.
What if it's something not me? That's not me. Still an insert. Mine popped out of insert.
Are you using G for easy or Gmail?
Gmail. It's GM easy. I don't know. I don't think that's what I was trying last. Okay. Unless you must remind us. insert and escape. But how should we say? I got it saved.
You can escape or no?
By escape. Okay. I think you just open it. Sorry.
Press stop. And there are a few other commands that I can use. I'm not expecting you to follow, but for example, colon set number. It's gonna label the number of the lines, and you press. So J, K, L, H are the keys to move the cursors to the up, down, and left and right. So for example, if I press Y, and then P, YY will copy that line, and press P is going to paste, okay? And then you see how I move my cursors around. It's using, so H is left, L is right, and K is up, J is down. See if you can do this. Yeah, so you just put the cursor on one of the lines and then press Y twice. And then just P. It's going to paste underneath that line. Did that work?
Yeah.
Okay. And you can select, also, there's another option. For example, you can select, it's going to be Control Shift V. And it's going to select all the lines, and you press single Y. And it's going to copy everything here. So just press the P, it's going to copy the entire block underneath it. So that is one of the reasons, the programmers are a lot of times they don't use mouse. They just use a keyboard to do everything. To speed up your coding a lot. That's not just the only reason for using Vim. It's just standard editing tool in the Linux systems. So can you move the cursors around? Can you do that over there? You? No?
Yeah, I don't select it. Then I don't know. You selected the whole thing then? Huh? You selected the whole thing? Yeah. Like every line? Yeah. How did you do that? Control Shift V. Visual block. It's not selecting the whole thing for me though. It doesn't select it, it just has like visual. Oh, I see. And then you can select it with the cursor. What's pasted? Oh, that makes sense. Okay. Okay, I yanked 8 lines. How did you do that? You have to, once you do the Control Shift Y, like, but I can't paste it out, just like do like up arrow and it's like select it. Yeah, Control Shift Y, up arrow, or J. Or is it Shift Y? Control Shift V. Yeah, into the visual block, and then you can up arrow and up arrow, and then you can yank it. That's what Y is. Okay. And then, oh, there we go. Okay, and then you can paste it. Can you delete? I've just been holding delete until it all went away. Block of copy lines. Then now you have to paste it. You yank it. Okay. I see. It just took one. Yeah, because if you just go up, it will only take that one. So how did you do it? You went up and over? I went up and then over. Like, it's so weird. Oh, you can just highlight in the visual block and hit delete all you want.
There are many commands on the website. So try every single one if you can. And there will be a quiz on it. So the format of the quiz is going to be, I have a little paper printed that has all the commands required for you to execute. For example, type this line in Vim, okay? and copy and paste it to the second line, and copy the entire block and paste it underneath it. Or move the cursor to the end of the page, move the cursor to the front of the page. Delete everything, delete a single line, delete a word, replace the word, things like that. Okay, so all the commands are available on the website. You know, so during the, for example, this is during the escape mode right now. All right, if I wanted just to replace, I think there's a way to increase the font size. Let me see if I can. Okay, so it's set GUI font equals asterisk. Let's try it. Set GUI font equals asterisk. So it's going to open up a window so you can have different options. For example, if I make it larger, you can make sure you can see it. It's better. Okay. I'll follow that. Colon set GUI font equals asterisk. Would you? So this will open up the window and you can select all different font sizes and styles. All right. So now it's more clear. So you can see, for example, I have a typo here, right? Primba, not print. So you can change that letter under in the escape mode. For example, I put a cursor here, and I just need to press R. R means replace, and then I type T. All right, it's going to replace that letter, and I press escape. Okay.
Did you like get it to take the modification? I'm like setting it and then clicking enter.
It doesn't have that size. Click on them, which has a bigger size.
Oh, I see. So this is
It's real miss they didn't have
Did you get some trouble?
set
GUI
font.
you do the whole little thing so it's for
Yeah.
Oh,
Oh, I see, okay.
oh yeah, the Lucidity and Consist.
that's UI social.
You get it? Font size? Yes. You?
Yep.
Let me see anything else.
Other things are standard commands in Linux as well. For example, you can see the cursors here, right? If I have a super long page of code, let me see if I remember that. So GG, so two lowercase g's, you press GG. Okay, so GG goes to the very top of the page. Type GG really quickly, two lowercase g's. And the uppercase G, just one G, it's going to the bottom of the page. It's very useful. Trust me. In the future, if you look at all the scripts in Cadence, oh my goodness, like, or the after you run a synthesis or the timing evaluation, you are getting like thousands of lines. There's no way that I can scroll down to the bottom. But a lot of times they will they show all the parameters of the simulation, but eventually the results of the report is at the end. So it's just press the uppercase G, you'll be able to see the bottom of the page and look at the results. It's very useful. Now we only have a couple of like 23 lines, which is fine. But if you have thousands of lines, it takes you 5 minutes to scroll down to the bottom. So that's why we need to know how to move the cursor to the bottom. And lowercase g's, two types, two prices will give you move the cursor to the front. And you want to change a new line. You want to add a new line, an empty line underneath it, which is going to be uppercase O. Uppercase O, you can see. Oh, sorry. Uppercase O is going to add a new line to the top of that line. and it's going to directly jump into the insert mode after you press it. But if you press just a lowercase o, it starts a new line underneath it, and it's also in the insert mode as well. You can also insert in the line, right? So you just have to press I. If the cursor is blinking on one letter, you press I, it's going to insert in front of it. If you press A, lowercase a, it's inserting behind it. See? Right? And if you press the uppercase I, it's inserting at the front of the line. If you press the uppercase of A, it's inserting at the end of the line. So free up your right hand to move around the mouse. It's just everything on the keyboard. Anything else?
Where did you get the numbers in this part?
Which number?
On the left.
Oh, set number. Yeah, no worries. All the commands are available on the website. I'm just doing some demonstrations. So after today's lecture, you'll take the time to work on it. I think the quiz will be next Tuesday. Well, next Tuesday. See, there's another one. You can even comment out multiple lines of sentences that are useful. Right? A lot of times in Arduino, you want to comment out a few lines. You don't execute it, right? So the way to do that is see on the website. I already opened it up over here. It's going to be a norm insert. Is that hashtag? It's the name of the sign. So insert the hashtag in front of all the lines. So I have to, for example, I escape from here. I want to comment out. I have to do a Shift V, and then I select these lines, right? And then I press Shift colon, and I press norm insert hashtag for these lines. And it's going to comment out these lines, right? If I select them and shift colon to enter the command mode and press norm, type norm and X. So X in Vim or in Linux scripting or the editing systems, it's a deleting command. So X is going to delete something. So for these lines, I select all these lines because these are commented out. So right now I'm going to uncomment them. So I just need to type norm X. So it's going to remove all the front symbols of these lines. So you can uncomment all this code. So still don't have to use your mouse to select and comment out some of them. It's okay or not following. I'm not expecting you are following because everything's available on the website. You will try them after this class. Okay, I'm just showing you what we can do here. If you can follow, it's good. If you cannot, which is okay. And now, for example, I'm done with my coding. This is also very frequently used command, which is you shift colon, right? If I just press a Q, it's gonna quit the editing without saving anything, I think. Oh, so I have to press Q and exclamation. So it's going to be quit and without saving. Okay. So now if I open it up using Vim, everything's gone. And the bad thing is I have to set up the GUI font one more time. It could be different in a different GUI system. For example, in Linux, you probably won't have this problem because they won't even allow you to edit the font size. So you don't have the problem. I'm gonna copy and paste and paste, right? So I colon W and Q. W is write. So you are writing into it and quit. So in this time, everything will be saved in there. So make sure you will put a W there as well before you quit it. Okay. And there are other features are really useful as well. For example, splitting the window into different sub windows. That I like that a lot because a lot of times you have different modules to add it at the same time. Let me see. I think that's SP. So SP is column SP is splitting the window vertically, and you can switch in between windows, the editors, using Control W. Oh no, WW. Wait, what's the way to switch it? Oh, Control WW. So Control WW. So it's going to switch the cursor to the other window, which is a really nice feature to have. Did you see that? See? So I can edit different modules by doing Control and 2 Ws. And if I set the GUI font equals this, let me see which one will be changed, or both. Also, both of them will be changed if you do that. And you could also split like VSP. VSP is a vertically split, this one. So you're getting a column in here, one more column of different modules, and you can save each one individually. So for example, I save this one as test2.v. No, I'm not doing that. How do I do that? There's a different command, I believe, to save it. Yeah, so there will be a different, because you generated different windows here, right? And they are all test.v. So I really want to save it as a different file. Alright? Oh, I can. So just colon and save. Do you see that? So now let's move to the other one. So how do you switch the cursor to the other one? For example, this one. Control WW, right? See the cursor's here? So that window is selected, and do a colon, save this guy as test3.v. Press enter. So see, this one has been changed to test3.v, but this one has been, let's switch back. So this is test, well, I think I'm just renaming them. Wait, test. Okay, so everyone is being, so it's saving the original file into a new file, right? But it's not opening up a different file in different windows. So if you want to open it up, I think we have to tab, put the cursor here, and for example, we just put a colon, test1.v, see if that works. No? Oh, we don't have test1. So colon test.v, colon test.v. Okay, so it doesn't work. So there must be a, remember that. So it should be able to open up different files in different windows. Okay, this shouldn't be just the same. I may have the solution on the website or may not. Let's take a look at it. Anyway, but you got a very basic concept about what's going on over here, right? Okay, so I think it's a lot of things going on for the first tutorial. We'll have another lecture on Thursday, and next week probably the first 5 tasks in the first tutorial will be due next Thursday. I think we'll give you more time to begin with. That'll be better. I'm gonna update the website and let you guys know. I'll send you guys an email on that. But don't expect too much things on will be posted to Canvas later. Everything will be on one site. So it's less confusing as well, I guess. I will send you notifications through emails. All right, any questions? No? All right. Good to see you guys today. We'll see you again on Thursday.
Like the IDE.
No, it's not ID. It's not just a text editor. Yeah. Vivado.
And then you like copy and paste it.
No, it's being loaded. It's like the files you have, like the Spice code files, you load it to.
You like tell it.
Yeah. So you don't have to really specific homework assignments, but definitely practice with the Vim, the commands. Prepare for the quiz next Tuesday. Huh?
That's for this week.
No, for after today. So Thursday we'll have more explained. So you'll be able to start with the Vivado, the Verilog coding. Yeah.
So I have a couple different ideas for materials that I want to get.
Uh-huh.
But before that, I want to have a PCB like designed and
Okay.
printed so that I can use the materials on
Okay.
the electrodes.
Okay.
That I'm having some trouble because the first time I used Eagle or anything
Yeah.
using circuits.
Yeah.
And so I'm looking for a little guidance on like who I can talk to help me out with the details on design and things like that.
Yeah.
Or if I should just like use your tutorials on your website. Are those good for?
Did you use that for circuit one?
Yes.
But you did a super simple Eagle.
Yeah, it was super simple and it didn't end up working.
Yeah, it works. Yeah. So the open drop can be a very good start to practice the Eagle PCB stuff. We can, because the DOT grant is just awarded. Do you have the contract with you? Yeah, the contract is due. No, I mean the expiring next year or was this year, this May probably, or
I don't have it with me.
why? No, I mean the time.
Oh.
Can you still log hours, or have you done that? You
I
have.
haven't logged
you
hours
haven't,
because
yeah.
I haven't like
That's
I don't
right.
have a PCB to show you, so I feel like guilty.
No,
doing hours when
no.
I'm like learning still.
No, you definitely log hours when you are learning. Definitely,
Okay,
please.
Like even if I'm like messing up.
Yeah, definitely. Yeah, definitely. Yeah. I need the money to be spent. You know, if you don't
Okay.
spend it, I have issues, right?
Yeah, okay.
So that's a goal of having students on the board because when they're learning, they're also getting paid.
Okay.
There's another thing I want to work on. I mean, the open drop